radio receiver fails, it is your job as a repairman to locate and repair the trouble as quickly as possible. No matter what type of receiver you're troubleshooting, the fundamental approach is the same. The technical manual for equipment will give you the information required for troubleshooting. For example, it lists the test equipment you will need. This may include a signal generator, an electronic multimeter, an audio oscillator, and a tube tester. Test equipment should now be switched on and allowed to warm up to normal operating temperature. This will prevent frequency drift and incorrect readings when the test equipment is used. Your first step in troubleshooting a receiver is to learn whatever you can about the history of the equipment and the nature of the trouble. The equipment may be accompanied by an operator's report describing the type of failure. This receiver is only described as having no signal output. The second step is to make a preliminary inspection. Here you use your senses of touch, sight, smell, and even hearing to discover possible defects. You may find a loose cable, a frayed wire causing a short circuit, a discolored resistor indicating that it is overheated, a missing tube shield, or a power supply switch on an improper setting. A different setting may also require a different fuse. When you have completed the preliminary inspection, you can go on to the next step. In some of the later tests, the receiver will have to be connected to a loudspeaker and antenna. Before applying power to the receiver, check the B+ and filament circuits for shorts to avoid doing any damage to the equipment. You will find the procedure for making B+ and filament checks described in the technical manual for the equipment. Use a multimeter to make these checks. To check the B+ circuits, set the multimeter to measure resistance. Then turn the function switch of the receiver to the off position. One test lead from the multimeter is connected to ground, the other to the B+ line. On this receiver, we will use a built-in test point. The multimeter shows a normal reading of 19,000 ohms, as called for in the technical manual. If a reading less than the allowable tolerance were obtained, it would indicate a defective circuit. Other settings of the function switch also give normal resistance readings, as listed in the technical manual. The B+ circuits evidently do not have any shorts. Additional procedures are described in the manual to cover the testing of the filament circuits. If you find a short circuit indicated, remove all interconnecting cables that carry power to the subchassis. Then, with the power turned on, replace the cables one at a time in the order stated in the test instructions. If the B+ fuse blows after the power cable to a subchassis is connected, there is probably a short circuit in that subchassis. If there are no shorts in the key circuits, your next step is to sectionalize the trouble to a major section of the equipment. Here is a simplified block diagram of a receiver with a power supply section, a radio frequency section, an intermediate frequency section, a detector, an audio limiter, a common audio frequency section, and a local and line output sections. After you have checked the key circuits for shorts, you can safely turn on the AC power to the receiver. Set the controls of the receiver according to the instructions in the technical manual for normal operation. Then tune the receiver across the band. The carrier level meter shows indications of station carriers. For sectionalization, we will use two of the receiver's output circuits, the local output represented by this loudspeaker, and a balanced line output, which can be measured by this line level meter on the front panel. The zero reading on the line level meter indicates that no audio signal is present in the line output. No response from the loudspeaker indicates no output from the local audio section. If there were a defect in either output channel, it probably would not affect the other output. Since the carrier level meter indicated station carriers, we can assume that the trouble is somewhere in front of the local AF and line AF sections. The next step is to divide the remaining stages approximately in half and determine which half should be checked first, the RF section or the AF section. Either section may be tested first, but usually it's more convenient to test the AF section because in most cases there will be an output indicator with the equipment. In this case, to test the AF section, we insert an audio test signal at this point. In this receiver, a convenient terminal test point is available and will be used to determine if the audio limiters and the common AF section is operating properly. This easily accessible point is at the diode load, or the input to the limiter. If a signal inserted here reaches the loudspeaker and line outputs, it will indicate that the sections through which the signal passes are operating properly. For an audio signal source, you can use either a signal generator or an audio oscillator like this one. Adjust the audio oscillator for a 400 cycle signal. Insert the signal into the receiver in the following manner. Touch one lead to the diode load terminal on the rear of the receiver. And ground the other lead to the chassis. Both the loudspeaker and the line level meter indicate an output. The indication is that the trouble is ahead of the diode load where the signal was inserted. You can therefore eliminate the stages after the diode load and the power supply as a possible source of trouble. We will now divide the remaining stages. We inject a modulated signal into the input of the IF section to determine if the trouble is in the radio frequency section or in the stages between the RF section and the limiter input. For this test, tune the signal generator to the IF frequency of the receiver and use a modulated signal. The IF frequency of this receiver is 455 kilocycles. This jack is the input to the IF subchassis. Connect one lead to ground and insert the signal generator lead into the input jack. This time, the signal is not passing through the IF subchassis as indicated by a zero reading on the line level meter. and no response from the loudspeaker. The trouble is now sectionalized definitely to the IF subchassis. The test lead from the signal generator is removed. Once you have narrowed down the source of the trouble to one section, you localize it to one stage or circuit. You accomplish this by again dividing the remaining stages about in half. This simplified section is actually made up of 6 individual IF stages and a detector, any one of which may be defective. In this receiver, we insert the test signal at the most convenient halfway point, which is at the output of the 4th IF stage. Remove the 4th IF tube. Connect the ground lead from the signal generator to the chassis, and insert the other lead from the signal generator into the plate pin connection of the tube socket. If you obtain a reading on the line level meter, it would mean that all stages after the 4th IF stage were functioning properly. But there is no output on the line level meter. This test indicates that the trouble is between the test signal and the output of the IF subchassis. Therefore, we must narrow the trouble down to one of these 3 suspected stages. To test the detector stage, a test signal could be inserted at the plate or output of the tube in the 6th IF stage. But first, replace the 4th IF tube and shield. Then remove the 6th IF tube. Then insert the lead from the signal generator in the plate connection of the 6th IF tube. The line level meter still indicates no output. The test signal is not passing through the circuit. You can therefore eliminate the remaining 2 IF stages in front of the signal generator input as a source of trouble. The trouble is now localized definitely to the detector stage. One of the components of this detector stage must be faulty. Your next step is to isolate the defective part. Very often the trouble will be a defective tube, so it's a good idea to check the tube in the suspected stage first. Use a tube tester or substitute a tube which you know is operating properly. This detector tube checks out all right, so it can be replaced in the socket. After first disconnecting the receiver from the AC power source, position the knobs attached to the chassis as stated in the technical manual. Then remove the IF subchassis from the receiver. After several screws and connecting cables have been removed, the IF subchassis is withdrawn. Then it is visually inspected for any obvious defects which could cause trouble. After the IF subchassis is removed from the receiver, use extension cables or jumpers to electrically connect the subchassis to the receiver. Then plug in the receiver AC power again. Use the technical manual to determine required voltages and resistances for the tube in the suspected stage. The plate voltage reading, taken at pin 1, should be minus 9/10 volts. To read this plate voltage, set the multimeter to read negative DC voltage. To simulate a received signal, use a 455 kC modulated signal from the signal generator. Insert it at the input of the IF stages. With this signal injected, you check the voltage in the detector stage. One lead of the multimeter is grounded to the sub-chassis. The other is touched to the plate pin connection of the detector tube socket. The multimeter indicates 0 voltage instead of the normal 9/10 volt. Something is evidently wrong in the plate or cathode circuits. Next, measure the resistance in the plate circuit of the detector. This should measure 40,000 ohms. Use the electronic multimeter to measure this resistance. Set it to read R times 1,000, a maximum of 100,000 ohms. Before making resistance measurements, the AC power must be removed from the receiver. One multimeter lead is grounded to the sub-chassis, and the other is inserted into the plate pin connection of the tube socket. Instead of 40,000 ohms resistance, the multimeter shows a very high resistance, near infinity. Study the schematic diagram of the stage again to determine which components may be causing this open circuit. Then check the circuit for continuity, one component at a time. Your first continuity check might be from the tube plate to the bottom of the secondary winding. To make this check, place one test lead on pin 1, the plate of this tube, and place the other test lead at the bottom of the secondary transformer connection. There should be a very low resistance in this part of the circuit. The multimeter reading indicates that there is good continuity in the circuit. Then test the continuity of the next component of the circuit, coil L502. To do this, the test lead is brought to the point at which the bottom of the coil is connected. This time there is a high resistance measurement on the multimeter, indicating an open circuit. Now that the trouble is isolated to coil L502, you can proceed to repair the equipment. While making repairs, be careful that you don't do any further damage to the receiver. For example, heat the solder joint only enough to melt the solder, and use pliers to separate the lead from the lug. Otherwise, by twisting and pulling at the lead, you can splatter solder in the chassis and possibly cause a short circuit. Always use the exact replacement part whenever possible when you're repairing radio equipment. Such procedure will ensure normal operation of the equipment when it's placed back into service. In replacing a part, put it back in the same position it was in before. Also, make sure you make a neat and firm soldering connection. Once the receiver has been repaired, check the resistance of the circuit again. This will give you a quick indication that the circuit is now operating properly. Again, you measure the resistance between the detector plate and ground. This time, the multimeter shows a normal reading of 40,000 ohms, as listed in the technical manual. Then check the resistance between the tube cathode and ground. The multimeter shows nearly zero resistance, as it should. Replace the tube in the sub-chassis, and don't forget its shield. When this has been completed, plug in the AC power cord from the receiver. Now you can again inject a signal into the input of the IF sub-chassis and determine if it passes through. Use the 455 kilocycle modulated signal from the signal generator. With this receiver, you inject the signal at the IF sub-chassis input jack. This time, both the line level meter and the 400 cycle tone from the loudspeaker indicate that the signal is passing through. Indications are that the trouble has now been corrected, and the IF sub-chassis can now be replaced in the receiver. The tuned circuits of a receiver must be correctly adjusted if they are to work at peak efficiency. This adjustment is called alignment. Alignment is often necessary when replacements have been made in high-frequency circuits. Alignment procedures are detailed in the technical manual. A signal generator is used to align fixed IF stages. One lead of the signal generator is connected to a built-in test point ahead of the fixed IF stages. The second lead is grounded to the chassis. The signal generator is then tuned to 455 kilocycles unmodulated. The multimeter is set to read negative DC voltage. Then the multimeter leads are connected to the diode load and ground. It will then measure the output of the IF section. After the meter is connected, plug in the receiver's AC power cord. Set the front panel controls on the receiver according to the instructions in the technical manual. Wait for the receiver to warm up before you attempt to align it. Now adjust the frequency control of the signal generator until you get a peak reading on the electronic multimeter. Your next step is to align the IF transformers for peak output, beginning with the last IF stage. Use an alignment tool or a screwdriver to adjust the core of the transformers. As you adjust the transformers, adjust the attenuator of the signal generator to maintain a reading of about 6 volts on the multimeter. The other stages are aligned in this same manner. The technical manual also gives instructions for aligning other circuits in the receiver. Before the receiver is returned to service, it is given a series of final tests to ensure that the equipment meets specified standards of performance. These may include tests for sensitivity, selectivity, distortion, audio response, and IF response. We will demonstrate a sensitivity test. A signal generator is connected to the balanced 125 ohm antenna jack. A 600 ohm, 1 watt, non-inductive resistor is attached in parallel to the local audio terminals. Now attach the leads from the electronic multimeter across the resistor. The signal from the signal generator can now be measured at the receiver output. Be sure the modulation of the signal generator is off. Then adjust the local gain control. Until the multimeter indicates 0.8 of a volt noise level. Then turn on the signal generator modulation and adjust its output until there is a 2.45 volt signal plus noise indication on the multimeter. The output reading of the signal generator in microvolts is the sensitivity for a 10-to-1 signal-to-noise ratio for AM signals. This sensitivity test is but one of the final tests normally made. There are several points to remember in troubleshooting a radio receiver. First, use the built-in meters or other test equipment provided in the receiver. A familiarity with their electrical locations and functions in the circuits can speed up your work. Second, the technical manual gives specific instructions on how to troubleshoot a particular receiver. And third, to find the trouble in the shortest possible time, divide the receiver into the largest convenient segments for tests, thus eliminating approximately half of the suspected stages each time. Finally, you can narrow down the trouble to one stage, then to the defective part. To review, first find out as much as you can about the history of the receiver and the type of trouble reported. Next, make a preliminary inspection of the receiver to find any obvious trouble. Then check the key circuits, that is, the B+ and filament circuits, to avoid doing any more damage to the receiver. Next, narrow the source of trouble down to one section of the receiver. Then localize the trouble to the faulty stage or circuit. Then use tube, voltage, and resistance checks to isolate the defective part. Be careful of unnecessarily disturbing circuit wiring or components when you repair the receiver. Align and adjust the receiver when necessary after repair. And make a final test of the receiver before you return it to service. By using this logical method, combined with your own common sense, you can learn to troubleshoot a receiver and get it back into service in the shortest possible time.